Okay, now 3.3, we want to review some formulas from Algebra 2. And this session, same thing is easy. We can quickly finish in one video. Now, from Algebra 2, we learned this formula. When there's multiplication inside the parentheses, separate become the addition. Now, actually, the idea is if the degree of u when you convert to base b, if the degree is x, and the degree of the v if you convert to the base b, the degree, for example, is y. Then when you multiply together, because of the same degree, so you are going to have the degree of x plus y. Now outside you have log base b. Outside you have log base b. So in this case, this log b and the b cancel out. In the end, you have equals to x plus y. Now actually, if you take a look individually here, this u is b to the x, and this v is b to the y. So when you cancel out this, that, then you also have x plus y. Now the basic idea is when you have multiplication for the base with the base, your degree need to be, your exponent need to be addition, and the log function basically is talking about the exponent when a number convert to become base b. So if u and the v multiply, then their exponent need to be addition. Let's follow the exponent rule, exponential rule. So this is the formula you want to follow. Now, ln basically means base e. So still follow the same formula. You may try. Another formula is when you have n on the exponent, this n can be bring out to outside, become coefficient, and it become multiplication. So that's one of the formula. I don't want to spend time to prove it for you, but this formula is really useful because sometimes we have very high degree. It is hard to deal with. So if you can bring down this exponential to the ground and become multiplication, the whole thing become easier. So, and we talk about the name of the property. When you have division, the exponent need to be subtraction. That's how you memorize this formula. And the name of the property, we call it quotient property because it's division. Now, there's another formula. Convert any base to the base you prefer. So, for example, if you have base 7, you may convert to become base 10. If I don't write down anything, means base 10. You can change it to base 10. Or this means you change it to base E. So this formula may allow you to change it to any base you prefer. So you want to change the base to 7 or 9 or 100, any number is fine, but usually we would like to convert to the base 10 or base e, because you may use calculator to evaluate the result. So when you have base 10, you don't need to write down 10 here. It means base 10. When you have base e, you can simply write down ln. That's a new notation to replace log base e. Now these two base, one is common base 10, one is natural base e, and you may use calculator to evaluate the final answer. So when you have base 8, it's hard to use calculator. But if you change to ln, then we can just use calculator, you input, and then you can find the answer. Now number 4 is a little special here. Even though the base 5, we cannot use calculator, but we won't like number 3, we change the base to base e or base 10. You don't need to. Why? Because here the input, sorry, let me rewrite. The input, you may just simply change the input to become same base, which is base 5. And because this on the denominator, so degree exponent will be negative. So 5 cubed supposed to be 125. Now you have negative 3 degree. And when you have the same base for the inverse function to each other, then you may cancel out to become negative 3. Or if you want to use the new formula, means you may bring this negative 3 to the front, become multiplication, and these two cancel out, is equals to 1. This is 1. That's another way to do it. Number 5, there's a fifth root. Fifth root, you use 1/5. And then you may convert 16 become 2 to the 4th. So you may have a same base. When you have same base, you simply cancel out, then that's the answer. You may skip this. You may skip this step. Number 6, when you have subtraction, if you try to use the formula we mentioned earlier here, where it is, this one, you need to make sure there's no coefficient outside. You can go back and forth. This formula may go this direction, or may go this direction. All fine, both fine. But remember, there is coefficient 1 here. Okay, coefficient 1 here. If there's not 1 for the coefficient, then you're supposed not to use this formula. So let's take a look at the question here. You have coefficient here. So when you have coefficient 5 to multiply, you don't supposed to use formula right away. Okay? You either want to bring 5 up there, but this kind of complicated because you have 5 degree and then you have another 5 degree, kind of complicated. So we don't do this way. You may do many other way. Now let's take a look here. And the very lucky case is ln means base e. So in this case, I will simply just let me rewrite. Okay, I rewrite this part here to separate them to become multiplication. Now ln and the e may cancel out. So end up with you have only 5 here. So 5 times 5, 25. ln e cancel out. You have only 9 left, so you subtract. That's pretty easy this way. Okay, now starting from number 7, you have the question type is kind of what do we want to do? How we simplify, or do we want to evaluate or anything? So I would like you to pay attention on the type of the question. Use the property to expand the expression. So all over the question after number 7, there will be 2 types. One type is you have a single expression. You have one single expression, and then you want to expand the single expression to become either a sum or difference or a lot of things together. Okay? So for this case, you have one single expression. You want to change it to multiplication and the division, multiplication and addition all together. How can you do that? So first, you use a formula to bring 7 outside to become multiplication. And then inside, when you have multiplication, you can separate to become 2 items plus together. So we use 2 formulas together. One is you bring 7, the degree, to become coefficient. Coefficient means multiply. And then you use another formula to separate inside the parentheses. When you have multiplication, you may separate to 2 separate logarithm function, and you have addition because this means exponent right now. And number 8, same thing. They give you one single expression, and you try to separate this one single expression to multiplication and the subtraction. Why is subtraction? Because we have division. Okay, so first, because that's division, you change it to subtraction. When you change it to subtraction, then you have 2 separate log. Keep the same base, 6. And these 2 you may bring down to the ground, become coefficient. So you have 2 times. Number 9. Same thing, you have one single expression, and because this division, you change it to subtraction. Now, when you have degree, you want to bring down to the front, become coefficient. Then you are done. Because, be careful, when you have division or multiplication inside the parentheses, when you have single term, you have multiplication or division, you may separate them to become addition or subtraction. But when you have addition inside the parentheses, there is no formula. No formula to separate them. So it's done. Okay. Next one is more complicated, but we just follow the same rule. This multiplication we separate to addition. And then square root, you change it to degree. Now we want to keep going. You bring 1/2 degree to become coefficient. So we almost there. And the same thing, 8 become coefficient, multiply. Now, next we have division here. Division means subtraction. Okay, and then we distribute. So you have the final expression with three separate logarithmic functions and connected by addition, subtraction, or multiplication. Number 11. Now start from number 11 is a backward. Right now I give you two separate expressions and connected by subtraction. Can you put them together inside just one log? Now the log base 5, you still keep base 5. And the subtraction means what? Subtraction means division inside one log. So when you have two separate log, the subtraction inside one log means division. Same thing here. When you have subtraction, it means division. But before you can use the formula, you need to make sure there is no coefficient in front. Then, before you can use the formula, you need to make sure this 7 is go up to become the exponent. Now, there's no more coefficient in front, so you can make sure the subtraction is division for one log. Number 13, it just become more complicated. Now, you cannot put 8 to become degree here. No, the coefficient only go inside the log to become degree. Like this 8 may go, this 8 may go inside to the log to become degree, but not this one, okay? Not this one. This one, you don't know where to go, so you just copy this 8, okay? Now, the only thing you can do is bring this 8 to the degree here and copy, okay? Copy. Whenever you cannot do anything, please just copy. Okay. Now, after that, subtraction. When you have the negative sign in front of the ln, then it means the denominator. You take away these two terms, means the degree has been taken away. So the whole thing need to be on the denominator. And this is positive, so it's on the numerator. So that's numerator and the denominator. Whatever is subtract need to be on the denominator. So you may multiply them together. And don't forget, you need to bring this number 8 inside the log function to become degree here. Now, you may stop here. Number 11, this is the word problem. Now, first they tell you what's I. I is the intensity. So you simply just replace this I by the given information. Now, find the difference. So, you have 2 beta, you need to subtract. So, the other one is this one. So, this one here, and the other one there. Okay, let me erase the mark. It's too ugly here. Sorry. Okay, so if you need to find the difference, then you need to use formula twice. So this will be the first formula, subtract the second formula, and according to the given, the first intensity here, second intensity there. So I and I, you have 2I here. So we say this I1, I1, and this is I2. You make this one I2, and the subtract. How we deal with subtract? Remember, we just learned, right? So when you want to subtract, you need to make sure you bring this 10 to the inside, become degree. Yeah. So you have degree 10. Now, why we want to make it so complicated? Because we have calculator. Okay, so if we bring 10 inside, according to the subtraction, you may change it to just the 1 log, become division. And take a look, you may simplify. I will leave all the calculation for you to try your own homework. But anyway, you follow the exponent rule. This degree 10 may be distributed here. So you have 10 degree for this number, and the degree to the degree we have. So let me do a little bit for you, okay? 1.12 to the 10 degree times 10 to the 5 times 10. When you have degree to the degree, it means multiplication. And I will let you try the denominator. And why I didn't finish here? Because just use calculator. Okay. Oh, sorry. Sorry here. Not this line. Not here. Our division is inside. Right. This one is inside. 4.5, 10. And 10 to the 7 times 10. Okay. And you use calculator just to simplify. Then you are done. Now these 2 questions, I don't think it's easy for you. You don't need to really do it, but I need to explain for you. This number 15 and 16, just guess and check. Okay, you find out. They give you x and y, and then you find out what's ln(x). You just ln1, ln2, ln3. You find ln(x) and find ln(y). After you find that, then you try to find the relationship between these two. Okay, so you just input the number and then you find, you put the ln, ln, ln. That's what it means. ln, ln. Okay, so you find it that you use calculator to evaluate. Do the same thing for this. and then try to find the relationship between these two numbers. It's kind of guess and check. So there's really no skill. And the number 16, actually myself have hard time to really find the relationship. And I just copy all the examples from our textbook. That's all the possible answer. Maybe something else. Okay? So maybe this way, maybe this, maybe that. Who knows? I think this is kind of hard for me to really, I think it's guess. So I may skip number 16, and if you are smart enough, you may try by your own. So I think I'm done with 3.3. So see you next time. Thanks.